Haley,
Yeah.
what happens when polygons break the law? Where do they go?
Where?
They go to prism.
Oh.
Haley, come here. What do you call a rabbit with fleas?
Uh,
Bugs Bunny. Haley, why did the Scarecrow win an award?
Why?
Because he was outstanding in his field.
Bobby Yamamoto.
Alright, so we're starting a new section, section 4-4, and we're looking at the different properties of logarithms. So a few things to remember is that, remember when we multiply two numbers together that have the same base but different exponents, remember that we add the exponents. So for example, that would be something like this. 2 to the power 3 times 2 to the power of 4. Well, that would be the same thing as 2 to the power of 7. You add the 4 and the 3. Now, how does that relate to logarithms? Well, remember with logarithms, a logarithm equals the exponent. So we're basically going to be using this concept of adding, but in the logarithms. So this is called, what we're looking at today, our first section, is the product property of logarithms. So what this says is that a logarithm of a product is equal to the sum of the logarithms of its factors. So basically, if you add two logarithms together, you can make that into a single logarithm and multiply those two numbers together. So two separate, here's first logarithm, second logarithm. If you add, you can combine into a single multiplying logarithm. Because a log equals the exponent, you take this and basically up here, you undo it since the log is equal to the exponent. So here is what it looks like using our variables, no numbers. And it works both ways, so the property above can be used in reverse to write the sum of logarithms as single log. It works both ways. So if I start out with, let's say I start with this, I could separate this into two different logarithms and take the imminent n and add them together. Or I could start with this and convert back to a single logarithm. We'll be doing that more often. It just makes your life a little easier. Sometimes you have to do it to solve the specific logarithm. But let's look at a few examples. So example A, let's say that we had log base 4 of 2 plus log base 4 of 32. Now one thing you have to make sure of, you have to make sure that the bases are the same. That's these two numbers, B and B. You have to make sure that they are the same. If they're different, you can't use it. Okay. So how do I convert this? How do I write this as a single logarithm? Well, I take, this would be m and n. That's m and n. So I can rewrite this as log base 4 of 2 times 32, which will give me log base 4 of 64. Now let's go and evaluate this. Let's set it equal to x. And what does x equal? Well, I recycle. I get 4 to the power of x is equal to 64, which means x would have to equal 3. So I could rewrite this as log base 4 of 64 equals 3. That's what that simplifies to. Now you could solve each of them individually, solve this one and then add it to this one. You get the same result. But notice that it's much easier to solve the single one. Let's do another example. Example B. Let's say I took log base 1/3 of 27 plus log base 1/3 of 1/9. Now let's go ahead and, again, you could solve each of these individually, then add them together, but notice that this one makes it a lot easier if I combine this into a single logarithm. So log base 1/3 of 27 times 1/9. Well, 27 divided by 9 is equal to 3. To get log base 1/3 of 3. Let's set equal to x, recycle, and I get 1/3 raised to the power of x is equal to 3, which means x would have to equal -1. That would bring the 1/3 to the top. So this logarithm, I'd rewrite this as base 1/3 of 3 is equal to -1. And that's it. So I have two more for you guys to try on your own. C and D. Example C, we have log base 6 of 4 plus log base 6 of 9. And we have log base 5 of 625 plus log base 5 of 25. So we're going to solve each of those on your own. I'd suggest pausing the video and trying them by yourself. But when we solve these together, write them as a single log, base 6 of 4 times 9. Well, that will give me log base 6 of 36. Set it equal to x and solve this. And we get 6 to the x is equal to 36. X equals 2, which means I have log base 6 of 36 equals 2. And I accept either of those for a solution. Example D, log base 5 of 625 times 25. We get log base 5 of 625 times 25. It's 15,625. Set equal to x. So 5 to what power is equal to 15,625? 15,625. Well, that would be to the 6th power. So 5 raised to the power of 6 will equal 15,625. Now another type of question you might see, I might say something like this. Write the following as a single logarithm. Let's say I had log base x of c plus log base x of y. How could I write that as a single logarithm? Well, this is just making sure you know how to convert. I get log base x of c times y. That's how you would do that. So you might see something like this on a test or quiz possibly. But it's just making sure you know how to convert or write them together. And you could also work the opposite way as well. Separate. Now on the same token, remember that if we divide powers with the same base, then we subtract the exponent. So if I take this guy right here, notice I have b to the m divided by b to the n, same base, different exponents. I could rewrite this as a single identity here, single number here, and I'll just subtract the exponents. On the same token, with the logarithm, if I divide down here, if I have a log that's dividing two numbers, I can rewrite it as a subtraction of two logs. So I could take the 16 over 2 and make it log base 5 of 16 minus log base 5 of 2. Now the one thing you do have to be careful of is that whichever number is on top, that 16, that comes first. Whatever's on the bottom, that comes second. So the order does matter here, as always with subtraction. Now here it is without any numbers. Works both ways. So I could start here. M comes first, and then n. Subtract both logs. Notice that the bases are the same. Have to have the same bases. Or I could work the opposite direction, as it says down here. I could start with this, and then since the m comes first, that goes on top. The n comes second, that goes on the bottom. So I could write it as a single logarithm. We'll probably be doing this more often, but it does work both ways. So our first example of dividing, look what I got. We have, so the type of questions you'll see will say something like this: express log base 2 of 32 minus log base 2 of 4 as a single logarithm, then simplify. So how do I take this and express it as a single logarithm? Well, I take log base 2 of 32 minus log base 2 of 4. Here's m, here is n, so I can rewrite this as log base 2 of 32 divided by 4. Make sure this goes on top and bottom, because the order matters. When I simplify this, and I get log base 2 of 32 divided by 4 gives me 8. Let's go ahead and set it equal to x. Solve for x, or recycle. And I get x is equal to 3. So I could write this logarithm as log base 2 of 8 equals 3. But again, either of these I would accept. Example B, when you divide, again, you're still going to express that as a single logarithm, then simplify. The example B, let's take log base 5 of 100 minus log base 5 of 4. Let's write it as a single logarithm and then simplify. So I can take this log base 5 of 100 divided by 4. Well, that gives me log base 5 of 25. Let's set it equal to x and then recycle. Now if it just said, back up really quick, if it just said write as a single logarithm, I could stop here. But if it says simplify, then I can continue. Set it equal to x and recycle. 5 to the power of x equals 25, so 5 obviously squared. X is equal to 2 equals 25. So this logarithm, log base 5 of 25 equals 2. And that's it. So it's pretty straightforward. You guys try one on your own. So go ahead and pause the video once I write it out. Attempt it by yourself. So log base 7 of 49 minus log base 7. Make sure the bases are always the same. So log base 7 of 49 minus log base 7 of 7. Now you could do this by yourself, or you could do this without making it a single logarithm, because 7 to the x equals 49, 7 to the x equals 7. So you would see that this is 2 minus 1 equals 1. You could do it that way. Solve each individually. But if it asks you to write as a single logarithm, you get log base 7 of 49 divided by 7. So log base 7 of 7. Set it equal to x, recycle, and you get x is equal to 1. So obviously with these, it's pretty easy to do each individually, but we'll look at some that are more complex that actually makes it a lot easier to write as a single logarithm. Last thing, you might see a question like this. I think I'm on example D. Log base z of x minus log base z of y. How would you write that as a single logarithm? Log base z of x over y. And that's your answer. So that's it. Pretty straightforward, pretty easy. Just remember that multiplying is addition for logarithms, and then dividing, this works both ways, the conversion, dividing is subtraction for logarithms. And that's how you make that conversion. So that's it. Email me if you guys have any questions, and hope you guys are staying safe, staying healthy. See ya.